In this video, we will discuss about applied physics laboratory Viva questions and answers, which are useful for all first year BTech engineering students. Photoelectric effect. During Einstein's photoelectric experiment, what are the changes are observed? The frequency of incident radiation is increased. As the frequency of incident radiation increases, the kinetic energy of the emitted electron increases as well. The and therefore the require more repulsive force to apply to stop them. How does the intensity affect the photoelectric current? Since each incident photon ejects one photoelectron from a metal surface, therefore the number of photoelectrons emitted depends upon the number of photons falling on the metal surface, which depends on intensity on the incident light. Hence, as the intensity increases, the number of photoelectrons ejected increases, and hence photoelectric current increases. Define threshold frequency. The threshold frequency is defined as the lowest incident radiation frequency below which photoelectric emission is absolutely impossible regardless of the strength of the incident radiation. What is the effect of intensity on the stopping potential? Changing the intensity of incident radiation does not affect the stopping potential. As the intensity increases, the number of photoelectrons ejected increases. However, the maximum velocity attained by them remains independent of the in- intensity of the radiation. It only depends on the frequency of the incident radiation. Planck's constant value. Planck's constant value H equals to 6.62607015 into 10 power minus 34 joule H inverse or joule second. What happens to the wavelength of a photon after it collides with an electron? A photon transfers a part of its energy to the collided electron, so its energy decreases and consequently wavelength increases. This is because the energy of the photon is inversely proportional to the wavelength of the photon. Which photon is more energetic, a red one or a violet one? A violet photon has more energy because the energy of a photon is given by E equals to hv. Since energy is directly proportional to the wavelength, that is violet is greater than red, the violet photon is more energetic than the red photon. What is work function? A work function is a property of a material which is defined as the minimum quantity of energy which is required to remove an electron to infinity from the source of a given solid. What is frequency and its units? The number of periods of or cycles per second is called frequency. The SI unit for frequency is Hertz. Relationship between H and H bar. H is a Planck's constant and H bar is a reduced value of H. 1 by 2 H by 2 pi is the same thing as h by 4 pi. They equal the same value. The equation should both have a greater than or equal, but equal is the most optimistic value. LCR circuit. What will happen if both capacitor and inductors are connected in a circuit? When a capacitor and an inductor are combined in a single circuit, the energy can be traded back and forth between them at a given time. This leads to oscillations in the circuit. Example is radio receiver. What is the quality factor? It is the ratio between resonant frequency to the bandwidth, that is Q equals to Fr by delta F, where delta F equals to F2 minus F1. What is impedance? It is the ratio between maximum voltage value to the current value. Z equals to V max by I. What is resonant frequency? The maximum or minimum current occurs at a particular frequency in the circuit is known as resonant frequency. LCR series circuit is called acceptor phi because the impedance is minimum at resonance. Define quality factor. The quality factor is the ratio of maximum energy stored in a capacitor or inductor to the energy dissipated by a resistor, or we can say that energy dissipated during one cycle of oscillation. Define resonance frequency. Resonance frequency. Resonance occurs when the value of inductive and capacitive reactors have equal magnitude but a phase difference of 180 degrees. This is known as resonance frequency of a series LCR circuit. What is the relationship between impedance and current in the series circuit? Inversely proportional, because in LCR series circuit the impedance is minimum at resonant, but we get a maximum current at that particular resonance. What is the status of current in series and parallel connections? In series, the current will be maximum, and in parallel, the current will be in minimum. LCR symbols, purpose, and units. The LCR represents inductance, capacitance, and resistance respectively. These circuits mainly deals with the communication systems and signal processing, radio receivers, telephone sets, and oscillator circuits. Inductance units are in Henrys, capacitance units are in farads, and resistance units are in ohms. The symbols are given as resistance symbol. Inductance is just like a coil, capacitor is just like a two parallel plates. LCR series circuit is called acceptor. Why? Because the impedance is minimum at resonance. PN junction diode. Define semiconductor. A semiconductor is a material that has an electrical conductivity value falling between the tough conductor such as copper and insulator such as glass. Its resistivity generally falls as temperature increases. Types of semiconductors with examples. There are two types of semiconductors, p-type and n-type semiconductor. P-type semiconductors are holes. Examples are aluminum, boron, gallium. N-type semiconductors are electrons. Examples are arsenic, antimony, and bismuth. Define p-type and n-type semiconductors. In an n-type semiconductor, an intrinsic semiconductor doped with phosphorus or antimony as impurity. In a p-type semiconductor, an intrinsic semiconductor doped with indium gallium as an impurity. What is Fermi energy level? Fermi level in a semiconductor is the energy level occupied by an electron orbital at a temperature of 0 degree Kelvin. Fermi level is the maximum energy point that an electron could reach at 0 temperature. What is knee voltage or cut voltage? The voltage at which the forward diode current increases rapidly is known as knee voltage or cut voltage. For germanium, it is 0.3 volts and silicon 0.7 volts. What is breakdown voltage? A breakdown voltage of a diode is a reverse bias voltage at which current increases suddenly across it. If the reverse bias is increased, the current through PN junction will also increases, resulting in formation of voltage called breakdown voltage. What is potential barrier? The barrier potential is the potential difference across the depletion layer between the P and N regions of semiconductor. What is depletion layer? Depletion layer is a region in a PN junction diode where no mobile charge carriers are present. Why diode has low resistance in forward bias and high resistance in reverse bias? Forward bias decreases a diode resistance because it acts like a closed circuit, and in reverse bias increases a diode resistance because it acts like a open circuit. What are the applications of diode? Voltage regulator, protects from over voltages, used in clipping circuits to shift voltage, used in rectifiers, used in clamper circuits. Characteristics of solar cell and LED. What is forward and reverse bias? In characteristics of solar cell and LED. What is forward and reverse bias? In a standard diode, forward biasing occurs when the voltage across a diode permits the natural flow of current, whereas reverse biasing denotes a voltage across a diode in the opposite direction. What is solar cell? A solar cell or photovoltaic cell is an electrical device that converts the energy of light directly into electricity by the photovoltaic effect. What is the basic principle of solar cell? The basic principle of solar cell is photovoltaic effect. What is the circuit symbol of the solar cell? The figure shows the circuit symbol of the solar cell. Which material is most commonly used for solar cells? Selenium and silicon. What is meant by fill factor? The fill factor is defined as the ratio of maximum power from the solar cell to the product of VOC and ISC. Which type of material is used for in solar cells? The most prevalent bulk material for solar cell is crystalline silicon. It is also known as solar grade silicon. Solar cell is which biased? Solar cell is unbiased. Define threshold voltage. The threshold voltage is the voltage over which, depending on the technology, a certain phenomena happens. Threshold voltage of a MOSFET is the value of the gate voltage when a conductive band forms between the transistor source and drain. Define ISC and VOC in solar cell experiment. The short circuit current is the current through the solar cell when the voltage across the solar cell is zero, usually written as ISC. The short circuit current is the largest current which may be drawn from the solar cell. The open circuit voltage VOC is the maximum voltage available from a solar cell, and this occurs at zero current. The open circuit voltage corresponds to the amount of forward bias on the solar cell due to the bias of the solar cell junction with the light generated current. Applications of solar cell. It may be used in to charge batteries, used in light meters, used to power calculators and wristwatches. It can be used in spacecrafts to provide electrical energy. Applications of LED. LEDs are used in numerical displays, optical modes for compellers, used in traffic signaling and lighting technologies, in calculators and digital watches. For burglar alarms, for infrared LEDs are used. Characteristics of laser diode. Requirements of laser. Grain medium or optical medium which supports population inversion. Source for pumping action. Fully served mirror called high reflector. A partial transparent mirror called output coupler. Laser beam. Applications of laser. Lasers are widely used in the fields of communication, computers, industry, scientific research, military operation, medicine. What is the difference between LED and laser diode? LED is an optical output in coherent, whereas laser diode is optical output is nearly coherent. For LED, no optical cavity exists for wavelength selectivity. For laser diode, the optical energy is produced in an optical resonant cavity. For LED, no spatial and temporal coherence. For laser diode, optical energy is a spatial and temporal coherence. For LED, the output radiation has a broad structural width, whereas for laser diode, the output beam has very directional and narrow spectral. State the essential components of a laser: amplifying medium and optical feedback, finally the pumping source. State some advantages of LED. It has a simpler fabrication. Since it has simple construction, the cost is low. It is reliable source of transmission. Give some important point photodetector materials. The important materials are INGAS and INALGAS. What is laser? Laser stands for light amplification by stimulated emission of radiation. It produces a powerful monochromic collimated beam of light in which waves are coherent. What is the characteristics of laser radiation? Laser radiation have high intensity, high coherence, monochromatic and high directionality with less divergence. The advantage of LED is long life, fast on and off switching, low operating voltage. Fiber acceptance angle and numerical approaches. What is attenuation loss? We define the attenuation loss as the reduction in power density of an electromagnetic wave as it propagates through space. Define bending loss. Bending loss is the attenuation occurring because of either a bend in an optical fiber that exceeds the minimum bend radius or an abrupt discontinuity in the core or cladding interface. Tell me about the critical angle. Critical angle is the minimum angle of an incident beyond which the total internal reflection occurs for light traveling from an medium of higher to one of lower reflective index. Define TIR. At angles of incident greater than the critical angle, the light reflects back into the originating dielectric medium. Hence, we call this phenomenon is called total internal reflection or TIR. Give the significance of N2 greater than N1. During manufacturing of fiber, certain impurities get in the core and cladding, so that the reflective index is slightly higher in the core than cladding. Thus, N2 is greater than N1. State some uses of optical fiber. Firstly, to transmit the information which are in the form of coded signals of telephone communication, computed data. Dielectric constant. What is electric dipole? An electric dipole is two charged objects with equal but opposite electrical charges that are separated by a distance. What is electric dipole moment? The electric dipole moment is a measure of the separation of positive and negative electrical charges in a system of charges. That is a measure of the charge system's overall polarity. The SI units are Coulomb meter. What is the difference between dielectric and insulator? The difference between the dielectric and insulator lies in its field of operation. Dielectrics are used to store the electric charges, while insulators are used to block the flow of electric charges. While all dielectrics are insulators, all insulators are not dielectric because they can't store charges unlike dielectrics. BH curve of a magnetic material. Why does BH curve lose energy? Energy loss due to hysteresis. Due to the continuous process of magnetization and demagnetization in the transformers, energy is continuously lost in the form of heat, reducing the transformer's efficiency. Figure shows the BH curve. H is magnetizing force, B is the flux density. From point O to A, as we magnetizing force increases, flux density is increases. If you reduce the magnetizing force, it reaches to a point B, which is called retentivity. Now, to make the magnetizing force zero, even the magnetizing force zero, there must be some retentivity. Flux density is called retentivity. Now, if you increase the magnetizing force in negative, then we will have coercivity at point C. By increasing the magnetizing force in opposite direction, we will get a again saturation point in the third quadrant, which is at point D. The same thing, same loop will be continuous. What is eddy currents? Eddy currents are the loops of electrical current induced within a conductor by changing the magnetic field in the conductor according to the Faraday's laws of induction. Eddy currents flow in the closed loops within conductors in planes perpendicular to the magnetic field. In planes perpendicular to magnetic field. What is Hall effect? When a current carrying conductor is placed in a magnetic field mutually perpendicular to the direction of current, a potential difference is developed at a right angles to both the magnetic and electric field. This phenomenon is called Hall effect. Define Hall coefficient. It is numerically equal to the Hall electric field induced in the specimen crystal by using current when it is placed perpendicular in a magnetic field of 1 Weber per meter square. Torsional pendulum. Define rigidity module. Rigidity module is a material property that describes its resistance to deformation under shear modules denoted by G, measured in units of pascals. Define restoring force. The restoring force is a force that acts on an object to bring back its to its equilibrium position after it has been displaced. Thank you for watching. Please share and subscribe if it is useful.